All right, y'all, it's time to talk about probability sets. So this is what happens when multiple probabilities are interacting with each other. We're going to first begin with one called an intersection. So when you think about an intersection, you probably think about when two roads meet, when two lines cross. This is when two probabilities are going to meet, or more than one probability is going to meet. So what an intersection is, it's when multiple events are occurring. And we're going to talk about how to find the probability that all of those multiple events are occurring. What intersection is most commonly referred to is the overlap of events. It's the idea that I am going to win the lottery and eat a sandwich. It's how the probabilities are happening at the same time. It's how the probabilities are happening together. So, because we're kind of lazy in math, we don't like to keep writing the probability of intersection this, intersection this. So we have a symbol that we've used to represent intersection. That symbol kind of looks like this, kind of looks like an N. We also use the word and to represent an intersection. So the probability of A and B, right? So that's the same as the probability of A intersection B, A and B. And again, since it's the overlap, if you're representing it on our Venn diagram down here, it's where they're overlapping. It's that location in the middle. This small little sliver right here represents where this probability and this probability both occur at the exact same time. So remember, in order for two things to be occurring at the exact same time, they must be overlapping, which means that probability is usually a little bit less than A and B. All right, so that's our overlap, which is when they both happen. Let's talk about our union. Our union is when this, that, or both events occur. It's kind of like the idea that anything can be true. Event A can happen, event B can happen, both of the events can happen. It's the chance that any of them might happen. At least one of them might happen. At least maybe I'll win the lottery, maybe I'll eat a sandwich, maybe both, okay? So it's the probability of getting at least one of the events, or the other, or both. So it's basically like saying yes to all of them. Yes to winning the lottery, yes to eating a sandwich, yes to them both. And it's represented down here on this Venn diagram as everything. So remember the difference here. Intersection was just a lower overlap. They had to both happen. A union is, okay, only A can happen, only B can happen, they can both happen. Again, because we don't like to keep saying A union B, we have a symbol. It looks like a U for a union. And we also use the word or. Winning the lottery or getting a sandwich. Or you can think of it as winning the lottery or getting a sandwich or both, okay? So it's all of these things happening at the same time. So again, that's represented as A or B. Okay, so this one's a little tricky because it comes with our first rule of probability. This is called the addition rule. Now I want you to star that because this is going to come in handy a ton because it's not always something we can represent visually. We don't always have that Venn diagram. When we don't have that Venn diagram, we can use this thing called the addition rule. The addition rule is a way to find all of the probabilities if you have three of them. So here's how it works. If you want to find the probability of A or B, all you need to do is the probability of A, the probability of B, minus the probability of A and B, okay? So pretty much it works like this. If the probability of me winning the lottery is like 1 out of 100, plus the probability of me eating a sandwich, maybe that's like 7 out of 10, and then the probability of them happening at the exact same time is maybe 2 out of 75. If I want to find the probability of all of these things happening, of this, or this, or this, I'm going to use this equation to get my probability of A or B. All right, so far we've got intersection, that's our overlap, that's our and. We've got union, That's everything here. And that is our OR. Let's talk about right now, though, this space out here, okay? Our very last one, if you go to the next page, is called a complement, okay? Now, not compliment like, oh my God, your hair looks so nice today. Complement is like a way of saying no in probability standards. It's the probability of things not happening. So look here, the shaded region is this outside. So remember, this was the probability of A happening, this was the probability of B, this was the probability of both, all of this is the OR, this is the not. This is a way of saying no. It is the probability that A or B won't happen. It will not happen, okay? So this outside area here represents the probability of A or B not. You know that old joke where you used to be like, hey, you look really cool, not, and then everybody would laugh? That's basically what we're doing here. It's meaning no, actually it's not true, it's not happening. To do this, we use a couple different symbols. The first is we can put a little C up at the top. So as you can see over here, we have a little C. Sometimes we use a little tick mark, a little comma, or sometimes we use a bar over it. So all of those can represent not. And again, I've been saying that word over and over again, but it means not. It means that it will not happen. So again, if we look at our picture right here, this represents that A is not happening, B is not happening, both is not happening. Okay, something else is happening. None of those are happening. I'm not winning the lottery. I'm not eating a sandwich. I'm not doing both. Something else is happening. None of these in this scenario are happening. Brings me to your second rule. This is your complement rule. Go ahead and star it. The complement of any given event can be represented as 1. So remember, 1 is the greatest chance, that's 100%, minus the probability of yes. So it's basically 1 minus yes gets you the no. So if I have a 1 out of 100 chance of winning the lottery, I can do 1 minus 1 over 100, and I can tell you, oh, my chance of not winning the lottery is 99 out of 100. So I have a really high percentage of not winning the lottery and a really low percentage of yes winning. So what we've got now is we've got our intersection, our union, and our complement. We're gonna put it all together and we're gonna talk about how the heck do I make then a Venn diagram. So let's take a look at example 1, and we're gonna talk about how to make a Venn diagram. So Venn diagrams are really nice, y'all. They are a way to show a probability situation and help yourself out to try and figuring out your intersection here in the middle, your union, your complement, okay? So this one says, draw a Venn diagram for the following situation and then answer the questions about the probabilities. 27% of the ice creams in a freezer at Dairy Mart are popsicles, okay? So our first option here, we're gonna label this first one as popsicles. And popsicles, just so we're clear, is going to be this entire circle. So let me show you guys with a different color here. This entire circle is popsicles, okay? So that entire circle gets us that 27, which I'm gonna put as a decimal, 0.27. And then it says 35% of the ice cream are chocolate, okay? So here's our chocolate. So again, using a different color here, this entire circle, entire thing here, my pen's kind of dying, sorry guys, represents chocolate. So anything in the green circle is part of the popsicle category. Anything in the pink circle is part of the chocolate category. And chocolate was 35, so I'm gonna put 0.35. Right here is our both. So our both is any popsicles that are chocolate, okay? So this is any popsicle, vanilla, strawberry, whatever. This is any chocolate. It could be chocolate ice cream, it could be a chocolate cone, whatever. This is our section of where they overlap, where they intersect. This is our chocolate popsicles. So just right here could be our strawberry or vanilla popsicles. Just right here could be our chocolate ice cream, our chocolate cones. This again is our overlap. So let's talk about how to make the Venn diagram then. So here's the important thing to know about a Venn diagram. The entire situation has to add up to the total. And in the cases of our probabilities, that means the entire situation has to add up to 1, right? Or 100%, okay? So we're gonna need that fact in the end because we're gonna have to figure out what's out here, what's our not. To do this first, we're gonna start with our both. We wanna start with our both because we're gonna do something with it. But remember, this is our both. This is our chocolate popsicles. So our chocolate popsicles is 15%. So right here in the middle, I'm gonna put 0.15, 0.15, okay? So 15% are chocolate popsicles. Now here's the common mistake now. The common mistake is for us to put our entire percentage here and say that popsicles is 0.27. But that's this entire circle. This part out here, which I'm gonna shade right now in green, this part right here represents any popsicle that's not chocolate, because this part has the chocolate ones already. So what we need to do is we need to take our total of 0.27 and we need to subtract the ones that we've already accounted for as chocolate. We're gonna end up double counting our chocolate popsicles and double representing them. So when I do our total amount of popsicles minus our chocolate popsicles, I get that there are 0.12, meaning there are 12% of the things are just popsicles, not chocolate ones, vanilla ones, strawberry ones, banana ones, but popsicles, okay? Same thing's gonna happen over here. So remember, this entire circle is chocolate, so we don't wanna put 0.35 in here, okay? This shaded part with my dyeing pink pen is going to be anything that's not a popsicle, but is still chocolate. So just like before, we're gonna take 0.35 minus the part that we've already accounted for, and we're gonna figure out, okay, that this is 0.20. So what this represents is the total amount of popsicles is 27%. The total amount of chocolate is 35. The total amount of both of them overlapping of our chocolate popsicles is 15. This 12 represents any popsicle that's not part of the chocolate ones, so our banana, our vanilla, our strawberry. This represents any of our ice creams that aren't a popsicle, so just our plain chocolate ice cream, our chocolate cones, okay? But we can't forget about the not. This is an ice cream shop. I'm sure this ice cream shop sells things that are not a popsicle and not chocolate. I'm sure you can walk in and get a banana split, which is neither of them. So we've got to account for this outside. So that's where this comes in handy. So remember, our total percentage has to be 100, or our total has to be 1. We're going to go ahead and we're going to take all of these right here, and we're going to do 0.12 plus 0.13 plus 0.20. That's going to represent this whole circle part. And when we do that, when we do 0.12 plus 0.25 plus 0.2, we get, oh, I have to type it on my calculator correctly. So let's say that again. 0.12 plus 0.15 plus 0.20, we get 0.47. This represents the union. So the union of all of these. This represents yes to being a popsicle, yes to being chocolate, yes to being both. So remember, this out here is known as the complement. So we have to do now 1 minus 0.47. So remember, the total, which is always 1, minus the yes. So 1 minus 0.47 gets us 0.53. That means 53% of the things that this ice cream store sells are neither a popsicle or chocolate, okay? So I know it's a little confusing. Let's make some sense of it by answering some questions. So remember, this stands for probability, for those of us who are a little confused. So probability of just a popsicle. So remember, our popsicle was represented as that green section, that entire green thing. So our popsicle is this whole thing. So remember, that was our 27%. So 7% of the things that the ice cream store sells happen to be popsicles. Now look at this little one. This says popsicle, but this means not. So this means how much is not a popsicle. So remember from our complement rule up here, if we want to get the no, we can do 1 minus the yes. So we're going to do 1 minus 0.27. So the total minus the yes. And that's going to get us how much is left over. And that's going to show us that there's 73% of their inventory is not a popsicle. So 27% is a popsicle. 73 is not a popsicle. All right, talk about our union. So remember from before, our union is everything in here. We've actually already calculated the probability of the union. We already did it when we made our Venn diagram. But remember, union is yes to popsicle, yes to chocolate, yes to both. So our union is all three of these numbers added together, which we did down here already. So remember, our union was yes to popsicle plus yes to chocolate plus yes to both. So our union was that 47% that we found earlier. Talk about our and. So this is popsicles and chocolates. Remember, this is their overlap. So here's the difference. Union means yes popsicle, yes chocolate, yes both. So yes popsicle, yes chocolate, yes both. Intersection and only means both. So popsicle and chocolate. That's just where they're both. That's just their overlap right here. So that's just our 15%. Okay, the last one, again, we already have this calculated, but let's talk about it again. Probability of popsicle or chocolate, but not. So that means it can't be a popsicle, it can't be a chocolate, it can't be either. So what I do a lot when I'm talking about not is to say, okay, can't be a chocolate, can't be both, can't be a popsicle. It's this leftover information. It's all the others. So I covered up all the things it couldn't be. It couldn't be chocolate. It couldn't be both. It couldn't be a popsicle. It's none of that. It's the leftover pieces out here. It's 0.15. It's 53% of their inventory is not chocolate and it's not a popsicle. That's all your vanilla cones, your banana splits, all that other good stuff. All right. Hopefully you guys are doing okay right now. We're going to really put those rules to use now. All right. Flip over to our very last page for us, guys, and let's put our rules that we learned to use. All right, so we're going to make sense of this problem. So it says, a new donut shop in town is trying to figure out what items will sell the most. Throughout their research at a local donut shops, they have found that first, 63% of customers purchase a donut. So we're going to write that information down for ourselves. The probability of somebody purchasing a donut is about 0.63, 63%. All right. Next, we have that 80% of people purchased coffee. So again, pause. Our probability of somebody getting coffee is about 0.80, 80%, okay? So we've got our two options here. We've got donut, we've got coffee. Next, they said 88% of the people purchased a coffee or a donut. So that represents as this, the probability of donut, and remember, or is our U, coffee. Remember what that means. That means they might have gotten a donut, they might have gotten coffee, they might have gotten both. So that full-on combo here is about 88%. Finally, though, what they want to know is the percent of people who did get the both. So they want to know the coffee and. So what they're looking for is the probability of getting a donut and a coffee. So remember what we have here is we have just a donut, just a coffee, and then any combo. These are the people that got donuts, these are the people that got coffee, these are the people that got both. They would like to single it out and they would like to get both. So here you can see there's a little hint. It says hint, use the addition rule. So if we go back and we take a look, this is our addition rule down here. So remember I said the addition rule allows us to figure out any of the missing pieces. So we can figure out one of the probabilities as long as we have the other three. So since we have in our situation the probability of donut, the probability of a coffee, and the probability of or, we can find the probability of both. So let's talk about that. So our addition rule goes like this. The probability of or, so the probability of donut or coffee, is equal to the probability of A, so that's donut, plus the probability of B, so that's coffee, minus the probability of donut and coffee. All right, so let's fill in what we've got. So remember, the probability of our or was represented right here. That was 0.88, okay? The probability of our donut right here was 0.63. The probability of our coffee right here was 0.80. And what we don't know is donut and coffee, so I'm going to put an X right there. All right, now we have ourselves a two-step equation that we can solve. So we might want our calculators out. That's okay. So what we want to do first is we're going to add 0.63 plus 0.80. Okay. So what we're going to do is we're going to carry down that 88, right? So 0.88 equals 1.43. And then we're going to carry down our minus x. Remember, x is what we're solving for here. Now we want to get this to the other side, so we've got to do our opposite operation. So we're going to do minus 1.43. That's going to cancel that out. So we'll do 0.88 minus 1.43. Misspoke there. We're going to get negative 0.55% equals negative x. Pause. Does that make sense? You're probably going, how do you have a negative probability? Well, take a look. There's a negative on this side. There's a negative on this side. That means if I divide the entire equation by -1, those basically cancel out. And we get our x equals 0.55. So here's what we just determined. 55% of the people order a donut and a coffee at the exact same time. So about half here order a donut and a coffee at the exact same time. So again, this is using the addition rule. Example 3 is pretty much the same. I'm going to have you guys pause the video for a second and go ahead and give it a shot. All right, hopefully you guys tried this out, but let's check it out. Remind ourselves that the addition rule is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. For our purposes, we just want to fill in what we've got. So we've got A is 0.70 plus B, which is 0.40. We have our union over here, which is 0.80, and what we don't know is our and. So we're going to put that in as an X. So once again, we will solve it just like we did above. So we're going to do 0.70 plus 0.4, and we're going to carry everything else down. So 0.70 plus 0.40 is 1.1 minus X. Again, we're going to subtract our 1.1. That's going to cancel out for us. So we're going to do 0.8 minus 1.1, and we're going to get negative 0.30 equals negative X. And like we said above, that doesn't make any sense, but since there's a negative on both sides, it cancels out, and we just get 0.30. That means, once again, that 30% do A and B. All right, you guys getting tired yet? We've got one last example for us. We're going to put it all together here, and again, we're going to make ourselves another Venn diagram, okay? So we did one before with percentages. This one's going to have data points. Same difference. What you want to remember are a few key details, right? The middle is the and, the outside is the not, the whole thing together is the union. So let's talk about this. So create a Venn diagram for the following scenario. Then answer the questions about the probability. At Richmond High School, there are 150 seniors. So pause right here. 150 seniors, okay? That is your sample space. Your entire thing must add up to 150. So remember before I said that it always has to add up to your total? And before our total was 100%? Here we're talking about data. So our total is how many people there are. So there are 150 seniors, okay? Then it says 70 own dogs, 30 own cats. So our situation, this entire circle is dogs. So remember before, that's this entire circle representing dogs. This entire circle over here represents cats with my lovely dying pink marker. Okay, that entire circle is cats. And then in the middle here is the both. So remember a couple things I said to you guys before. First, since this entire circle is dogs, this entire thing is 70. Not just this part. The entire thing is 70. Since this entire thing is cats, the entire thing is 30. Not just this part. So what we want to do when we make our Venn diagram is start with the both. So 25 own both. Remember, we start with the both because this 25 is in this cat total. This 25 is in this dog total. Because what we do now to find these outsides is some subtraction. So if the total amount, this entire green circle is 70, and we've already put in 25, we're going to do 70 minus 25 to find out how many people just have a dog. So remember, this whole thing is just dogs in general. This is dogs and cats. This right here is just dogs, just only dogs. So we have to do 70, our dog total, minus 25, and we'll get that 45 people have just a dog. No cat, just a dog. All right, so then again with the cats, this entire circle is cats, so 30 people have a cat. 25 of them are already accounted for. So again, if we want just the cat part right here, we're gonna do 30, which is our cat total, minus our both, 25, and we get 5 people have cats. So again, let's talk about these numbers. 70 people just overall own dogs. That includes the people that only own a dog, and that includes the people that own both. 30 people in general own cats. That includes the 25 with both and the 5 that just have cats. 45 only have dogs. So this is like me. I only have a dog. 5 only have cats. Okay? 25 have both. So let's get our 3 probabilities. So let's remind ourselves. Probability of cat and dog. Remember, this means and. And is our overlap. But remember, refresh yourself on those probability rules. The probability is not 25. Probability is always your outcome over the total. Well, the total here is 150. Okay? Now we have the probability of cat, you, dog. Remember, you means or. So remember, that's the probability of cat. Cha-ching. Plus the probability of dog here, plus the probability of both. So that's all of these numbers added together. So that means it's okay to be cat, which is 5. It's okay to be dog, which is 45. And it's okay to be both, which is 25. So we're going to add 5 plus 45 plus 25. We're going to get 75. But again, probability is not just that number. It's over the total. All right. Then we've got this thing. We haven't seen this one yet. We've been seeing a lot of the C notation. But remember, C means not, so does this bar. So this means the probability of cat or dog, but not. This means it cannot be cat, it cannot be both, it cannot be dog. So it's that outside part. We need to make sure we figure that outside part out. So this is the part students always leave out, is that outside part. So remember, to find that outside, you do the total right here, minus the yes. So this outside part here will be the total, 150, minus the 45 that have dogs, minus the 25 that have both, minus the 5 that have cats. So it'll be 150 minus 45 minus 25 minus 5, which gets us 75 people. This represents our not. This is the people that don't have a cat. This is the people that don't have a dog. This is the people that don't have both. It's none of these people. There are 75 seniors that said they didn't have either of these cats. Maybe they have an iguana, maybe they have a bunny, who knows? And remember, that's always gotta be out of the total. All right, guys, so hopefully that helped you out. That is our probability set.